When looking at the structure of an atom, we need to look at how the electrons are arranged around the nucleus of that atom. So electrons are arranged in energy levels that are numbered, starting with 1 being the lowest energy level going up, and each energy level has a maximum number of electrons. So energy level 1, which would be closest to the nucleus, has the least amount of energy, and that can have 2 electrons in it. Energy level 2, which is the next furthest away from the nucleus with the next highest amount of energy, can have 8 electrons. Energy level 3 can have 18 electrons, and energy level 4 can have 32 electrons. It obviously keeps going higher with energy level 5, 6, etc. But for your level, all you need to know is up to energy level 4. So now each energy level has what we call subshells in them, and each subshell can hold its own amount of electrons. So subshells are usually lettered instead of numbered. So we have an S subshell, which can have 2 electrons, P subshell, which can have 6 electrons, and D subshells, which can have 10 electrons. Now, each one of these subshells can hold a certain number of electrons in what we call an orbital. So an orbital has a specific shape, and it holds 2 electrons in each. So the S subshell has 1 orbital of 2 electrons, and that is usually spherical in shape. The P subshell has 6 electrons, so it can have 3 orbitals of 2 electrons each, and that has a figure of 8 shape. And then the D subshell can have 5 orbitals because there's 10 electrons with 2 in each, but you don't need to know the shape of that. Okay, so we have a subshell, which is made up of orbitals, and each subshell makes the energy level. So first energy level has 2 electrons in it, so it is made up of just 1 S subshell for the 2 electrons. The second energy level, so let's write that down. So we have the first energy level made up of an S subshell. The second energy level of 8 electrons is made up of an S subshell of 2 electrons, and then a P subshell of 6, because 2 plus 6 makes 8. So we have S subshell and P subshell. The third energy level is made up of an S subshell for 2 electrons, plus a P subshell for 6 electrons, plus a D subshell for 10 electrons, because that all together makes 18. And so on and so forth. So we only have to know up to about that level. But now we need to know how to fill these. Okay, so if we arrange our energy levels from lowest amount of energy all the way up, so this is increasing energy. So at the very bottom, our lowest amount of energy is going to be the 1s. So that then moves to the next energy level, which will then be 2s, having small amount of energy, then 2p, which will move up to the next one, which is then 3s, followed by 3p, and then you would expect to have 3d. But the 4s energy level has less energy than the 3d one. So we have 4s to be filled before we fill our 3d orbital. And then we move on to the 4p orbitals, and then 4d, etc. So we will fill the 4s before the 3d, even though it's a higher number. When you write it down, under the electron configurations though, you will write them in order number. This is just so that you know how to fill those electron orbitals. So once we know the order of our energy level and our subshell and our orbitals, what we will end up writing is an electron configuration. So electron configuration will look something like this. So first the energy level, then the subshell, and how many electrons are in the subshell. So we will go up in order as we fill our number of electrons, etc., etc. So when we're arranging our electrons in our different energy levels and our orbitals on top of our subshells, we arrange them starting from 1 being the lowest energy, going all the way up to 4 or 5 and further. So in order, we start with 1s, okay, and then remember each one of those has an orbital. So the s has one orbital for 2 electrons, then 2s, 2p has 3 orbitals for 2 electrons each, with a 6 in total, and so on. So now, in order to arrange our electrons, I'm going to do the electrons using 2 different colored Smarties that you can follow along with. So the first thing I'm going to do is a key of my different colors, and I draw 1 electron with an up arrow like that. And let's say I'm going to make that one the blue one, and then I draw the other electron with a down arrow like that, because each orbital has 1 electron that is spinning one way and the other electron that's spinning the other way. That's why we draw 1 up and 1 down. So each orbital needs to have the 2 electrons. So when we're filling our orbitals like this, the first thing I'm going to do, so let's say I choose the element oxygen. So I have oxygen. I look on my periodic table and I see oxygen is element number 8 on the table. So oxygen is number 8, which means that it has 8 protons and 8 electrons when it's neutral. So now I need to fill the orbitals to be able to show the electron configuration. So I start at the bottom and I say there's 1 electron in the 1s. And then 2 electrons. So now I've filled the 1s orbital. So I move to the 2s and I say 1 electron, 2 electrons. So now I've filled 4 electrons. Then I move to the p orbitals. So now I say 1. So I've only half filled this orbital. So I say 1 electron. Then I go to this one and I say 1. And then this one. So I always half fill first before I can pair them. So now I have 1, 2, 3, 4, 5, 6, 7 electrons. All I need is 1 more, and then I'm going to start to pair it. So this is then oxygen. And from there, I can write down the electron configuration, and I can say that there's 1s. And in the s orbital, there is 2 electrons. So I can say 1s, 2. Then 2s, and there is 2. And then 2p, and there is 1, 2, 3, 4 electrons in the 2p. So that is the electron configuration for oxygen. So if I take those away, and now I can choose a different one. So let's say now I want to look at something like potassium. So potassium is number 19 on the periodic table, which means it has 19 electrons. So if it has 19 electrons and I want to fill them, I'm going to do it the same way. So starting with 1s, I say 1 electron, 2 electrons. Then moving to the 2s, 1 electron, 2 electrons, 2p. First, I half fill each one, and then I combine them to get 6 in total. Then I move to the 3s, which has 2 electrons. 3p again, first you half fill them, and then you pair them. Okay, so now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 electrons, and I need 19. So now, remember I said, first you fill the 4s before you get to the 3D, even though you write them in numerical order. So now that last electron is going to go here in the 4s, not the 3D. So when I write my electron configuration for potassium, I can now follow, and I say 1s2, 2s2, 2p6, 3s2, 3p6, and then I say 4s1 for that electron configuration. So now if I look at a different one that has something in the 3D orbital, let's look at, for example, iron. So if I look at iron on the periodic table, that is number 26. So if it's number 26, it means it has 26 protons and 26 electrons. So starting at the bottom, you fill 1s, then 2s, then 2p, where you half fill each one, then you pair them, then 3s, 3p, half filling before pairing. Okay, so now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 again. So now I fill the 4s first, so now I can pair it, because now I've got 20. So now I'm 6 short. So now after filling the 4s, then I can start filling the 3d. And the 3d gets filled the same way as the p orbital. So first, I half fill each one before I can pair it. So now I'm sitting on 25. So 26 will be there. So I have one fill orbital, and then the rest are all half filled only. And now if I want to write that electron configuration down, I say 1s2, 2s2, 2p6, 3s2, 3p6. Then you write down the 3d first, okay, because we write it numerically, even though I filled the 4s first. So now I say 3d, 1, 2, 3, 4, 5, 6, and then 4s2 as the electron configuration.